This is 7.3 beta. And again, if you're looking at the headings of the PowerPoints, they're misleading because it's saying day 1, 2, 3. We're doing day 1 last. That's the gamma lesson. So the shell method, and to go up here, ready? Here's the distinction. If you are perpendicular to the axis of rotation, if your slice, your rectangle that you draw in there, when you physically draw it or you imagine it, if it's hitting the axis of rotation is perpendicular, then that is a washer. And it could be a disc. A disc is a subset of washers where the inner radius is 0. But a washer is a more general term for them. And if you're parallel to the axis of rotation, meaning when you draw that cross cut, if it's parallel to the axis of rotation, that is a cylindrical shell. And these words kind of confuse me, because cylinder and shell are synonyms. So you have a cylindrical shell, or you have a washer / disc. The shell goes in parallel. They run, right? And the disc goes with perpendicular. They run. Disc runs with perpendicular. Not really, but shell does run with parallel. So suppose we have this. You have y equals x squared, the line x equals 2, and the x-axis. And you want to revolve it around the y-axis. Can you imagine this? And I want you to think about what this picture is going to look like before we just roll out the slide. Yeah, it's going to be a washer up above. So now what? Well, first off, look at this is what we're talking about. See that green cut? That green cut is perpendicular to the y-axis, the axis of rotation. This thing is hitting the y-axis at a right angle. So that's telling you it's a washer. That's the alpha lesson. Now, if you want to do a washer method, we see this? Then these discs are stacked vertically. They're dy's. So you have to solve these things for what x equals, because you needed x in terms of y to do dy. Is it logical? Some people are nodding their heads. You need to focus on what we're saying, because we're moving on. I can spend a lot of time with AB on this because they're almost finished the curriculum. Okay, we got 3 full chapters to do. We're not going to spend as much time on volumes and areas as they are. You need to focus. All right, so I see what happened. They did this. They rewrote this thing as what does x equal. They took the square root of both sides, and they got x equals the positive and negative root of y, take away 1, but you only need the positive root because you're in quadrant 1. Okay? So from 1 to 5, 1 up, you have a washer. You got a hole there. So what are we going? Big R squared, take away little r squared. So big R is 2 squared. 2 take away 0. Little r is the curve take away 0. And on the PowerPoint, they didn't write subtract 0, which I think is careless. It doesn't bring anything to the calculation, but it helps you understand what's going on here, because you're doing right take away left. Then what? Well, this is a washer, and that's a disc, because there's no hole in the bottom from 0 to 1. But what did they do from 0 to 1? They used geometry to get the volume of that disc. They didn't anti-differentiate. You get the same answer. So they said plus pi times 2 squared on what? The radius is 2, pi r squared. Pi r squared times how tall it is. Well, it's 1 tall. So you got pi r squared, which is 4 pi times the height of 1. So down here you would have 4 pi. And up here you would have this. Big R squared, take away little r squared, times pi. Yeah, I don't like, see, that's really confusing. Calling that a cylinder, it's a cylinder, but it's a disc. All right, they're kind of mixing up the disc and the way we're approaching this. So now what? Well, 2 squared is 4. You square what's in the parentheses, or you square what's on the root sign, you get y take away 1. This works against the root sign because it was pi r squared. Yes? And that 4 pi that they're adding over here is from 0 to 1. So we're going to anti-differentiate what you have. And you get 5y to the 0 plus 1 divided by 1. Y to the first plus 1 divided by 2 from 1 to 5. And it takes you here, 12 pi. Which is, who cares about 12 pi? Ready? What matters is this. This line right up here. Where are we getting that line? We're doing the problem dy, and we're saying the big radius, the outside radius is 2 squared. The inside radius is this thing squared. It's actually this one is more important. That's after you distribute the exponents. And then the lower integral from 0 to 1 is going to give you 4 pi. Okay? But if you think back to this, it's like we did in 7.2. And in 7.2, there were questions. There's one question, one example, multiple questions in the back, where if you did the problem dx, you had to do 2 separate integrals. You can rewrite the problem dy and do it in 1 integral. Okay? So here, we're not doing area, we're doing volume, but we can say it's a similar approach. So this is different. Totally different way to do the problem. This is what you need to get your mind around. This is the cut. But you're still going around the y-axis. So this cut is not perpendicular to the axis of rotation. It's parallel. Some problems lend themselves to be done either way. And you could say, well, I prefer this, I prefer that. But some problems are going to force you to do it this way. And that's why you need to get your mind around this. You can't say, well, I'm going to push everything. Like, I have a little bit of comfort now with washer, so I'm going to do every problem as a washer. Yeah, you would get most of the problems right. Okay? You want to be a STEM major. You think you want to be an engineer. We got no time for people that don't want to learn the material. Oh, I just want to do things this way. Yeah, okay. Next. There's the picture. And again, these graphics are really helpful. What did you do? You have these cylinders. That's just one of them. They're nested. You know what nested means? Like nested dolls, when you open the doll, there's a doll inside, a doll inside that, doll inside that. All these cylinders are nested. That's just one of them. You got a cylinder outside here, outside the green one, and another one outside, and all these inside. You got all these cans. Cylinders and shells mean the same thing. They're cylindrical shells. But if we take the volume of one of these and add them all, well, surface area of one of them, and then nest them and add them all up, we would get the volume of what's in the between the curve when it's revolved around the axis. So the volume of a thin cylinder is this. The surface area times how thick it is. So think about this. You've got this can of Coke. Surface area means, lateral area means no top and no bottom. So you have this can of soda. And you use a can opener, you take the top off. And you take the bottom off. That's the lateral area. So here's your can. No top and no bottom. And then you cut down on the seam and open the can up. Yes, I can imagine this. What are the dimensions of the can? What? Yeah, it's lifetime good. You got to be a little more specific in terms of the can. Correct. This is the height of the can. And the top would be the distance around it, which is the circumference, which would be 2 pi r. So if you think about it, you have all these nested cans. That's my blue nested can. And on the PowerPoint is the green nested can. And you took all these nested cans and you added up the surface areas where the thickness, multiplied by the thickness, which in this case we see is dx. Can you see that? How thick it is in that picture? Because the cans are standing up. So it would be dx thick. If we add them all up, we would get the volume. So there's the circumference times the height times the thickness. So the thickness in this problem is dx, the circumference 2 pi r, times the height, is what Brandon said, my advisee, times how thick it is. Now what? Well, r, the radius of the can, is the x value of the function. Take a look at this picture. There's the radius. It's how far you went to the right for that can. The height is the y value. It's where the green can is hitting the curve. It's x squared plus 1. And the thickness is dx. So what do we get? 2 pi x, 2 pi, where the radius is x. and the height is the y value, x squared plus 1 times dx. And what? We add them up from what? From 0 to 2. Because the radius of these cans would start with a radius of 0 to a maximum radius of 2. 0 to 2, this ready, bring the 2 pi out, it's a constant, distribute the x over what's in the parentheses, then anti-differentiate doing the power rule in reverse, evaluate that, 0 to 2, the zeros are going to give you 0. The 2 gives you 2 to the 4th, which is 16 times 1/4 is 4. 2 squared is 4 times 1/2 is 2. You get the same answer. You get the same answer as when we did the problem, or when they did the problem in the PowerPoint, perpendicular to the axis of rotation. Cylindrical shells. All right? So this is what we're going to do kind of fast. So just look what happens. That's a y problem. Y equals this. Okay? You want to go this way. You want to go around the y-axis. So if I want to go around the y-axis and I want to make my cut perpendicular to the axis of rotation, I have to solve this for x. It's an algebraic mess. This problem is an example where they're forcing you to do the problem. Dx. You don't have an option. So you would have this. 2 pi, 2 pi the radius. The radius is your x value. The height's the function. Dx. From where? Starting at 2 and ending at 8. You got a hole in there. We don't have to worry about the hole, because we're saying only count the shell that started 2 and ended 8. You don't have to subtract anything. Okay. So that last slide is what we wrote on the board. If you're going parallel to the axis of rotation, it's a shell. If you make your cut perpendicular, it's a washer, which subset of washers are discs. Right.
That last slide, how come the radius was outside of the anti-gravity? Was that already pulled down?
No, it's not outside. Ready? The radius is here. It's inside.
No, it's in parentheses.
Yeah, because they put this all in parentheses because this whole function was so convoluted. So the 2 pi can come out, but the x can't come out.
I didn't notice it.
That's fine. Now, you're going to need to do this. You're going to need to come back to the PowerPoint at your own pace. You ignore the work on this section at your own power. You will get lumped up on an assessment on volumes if you're trying to ad-lib while you're taking the assessment. Okay? Some people need to get lumped up. So, how about this? Let's start from a question at the end. True or false? A region enclosed by the y-axis, y equals 2 root x, is revolved around the y-axis, and the volume is given by this. Let's draw what that would look like. You would say, I got the y-axis, and y equals 2. and y equals root x. And you want to take that and revolve it around the y-axis. Right? You need to do this. Like if that's the question, you need to draw the picture and then say if that's what's being asked. We good? We'll come back to that. I just want you to say, okay, I can make sense of what's being asked. So this is the handout, except what? I just put the right side of the purple paper on the PDF. Because if we're going parallel to the axis of rotation, you're using the right side of that paper. And we're going to go to example number 4. Let me bring that up. So here's the picture. You have the curve, y equals root x. The x-axis. The x-axis and x equals 4. X equals 4. And you're taking around the x-axis. You're taking around the x-axis. All right, we're going to pause this for a second. So we're back here looking at example 4. And what they're trying to do is take this area, which you see is bordered by root x, x equals 4, and the x-axis, and they're spinning it around the x-axis. And you get that can right now that's sitting on its side. Does that make sense? So when we do this, we're going to be doing this problem dy, which is different than the problem on the PDF. I'm sorry, on the PowerPoint. Yes? Because this can is sitting on its side. And the can on the PowerPoint was standing up. You need to take a moment and get your mind around this. So now what? Well, I go back to the PDF, and I'm saying this. To set up this volume, I'm going to do 2 pi RH. And the radius of that can is the Y value, the height of the can. Make sense? You got to go back and forth between the two, between the PDF and the textbook. The radius of the can is going to be Y take away 0. The height of the can is given to be right take away left. It's that red line. The red line is the radius of the can. The height of the can is Y take away 0. That's backwards. There's confusing me. The shell rate, the radius of the can is Y take away 0. The height of the can, ready, is right take away left, which is 4 take away Y squared. So now I go back to the PDF. 2 pi radius. Y take away 0 times the height. The height of the can is right take away left. 4 take away y squared. Now what? You bring the 2 pi out front. You're going from 0 to 2. We're doing the problem dy. Distribute the y over what's in the parentheses. Power rule in reverse. And it takes you to 8 pi, which we don't. The 8 pi is less important than that top line, how we set it up. So we have 11 minutes. Here's what's going to happen. On the calendar, we're going to come back to a PDF, or I'm sorry, an FRQ about the shell method. So I will deal with this little disruption. If you're at home, you are going to go do the exit ticket. If you are in the building, we're going to go, now, if you're at home, before you leave, there is a PowerPoint. We're going to 33, just part A. We're going to try and deal with that question and set it up. There's a PowerPoint for 33, A, B, C, D, if you're at home. If you're here, you're going to problem 33, and you're trying to set the problem up. 2 pi times the radius times the height. You need to take out your homework book and a pencil, not just stare at the Chromebook. Okay? You're using what's on the PDF as your model. And we'll go through that between now and the period's going to end at 10:24. So for 33A, you have 2 pi, the limits are 0 to 1, 2 pi. The radius is y take away 0, and the height is the x value, 12 times y squared, take away y cubed, take away 0. And if you go here, in the Chapter 7 folder, there is a PowerPoint for problem 33, where they come out one screen at a time. Okay? So I'm looking at A. We're taking that picture of the x-axis. There's the picture, and I ended up with that part when I drew it that shows up in the fourth quadrant, which we didn't want. But you go by the picture in your book. As you proceed to the PowerPoint, it's doing this one step at a time. And on the PowerPoint, I did write take away 0. Well, the answer is secondary to you being familiar with what's on the slide that says 2 pi, y take away 0, x take away 0, dy. And then you can follow the PowerPoint to get the substitution of the values and to get the volume of the shape. Okay?